Hi grade 9s, unfortunately I'm not in our class today, so I've made you a short video to help you get started with this. Today we're back looking at our unit booklet. We're at the start of this still, so we're doing a bit of algebra review. What I'd like you to do is to find page 6. Today we're going to focus on combining like terms, which I'm hoping is review for all of you. There's some really useful notes on this page, but there are also some notes that I think are a bit confusing, so I would like to go through some of this. The first thing that I'd like to look at is actually right at the top of the page, because I think there is this equation right up here, and it's really helpful because it's got some of the terminology that we use. So you can see that the brown terms, the 7 and the square root 2, they are called constants. There are no letters involved in them, they're just numbers. They're called constants because they don't vary at all. We can't change them. 7 is always 7. You can see that the 5x is made up of a green part, which is called the coefficient, and a red part, which is called the variable. Sometimes these are called unknowns as well. The 5 is the coefficient because it tells us how many lots of the variable we want. The whole thing is called an equation. The left-hand side of this equal sign is equal to the right-hand side, so it's an equation. The left-hand side is an expression and the right-hand side is an expression. And it's made up, this whole equation is made up of terms. We're focusing on terms today, and we're looking at trying to simplify expressions by simplifying the terms, by combining terms. The terms are the things that are separated by the plus or minus signs. So you can see here the 5x is separated from the 7 by that plus symbol. So 5x is a term and 7 is a term. So what we're trying to do is to combine the like terms. That means the terms that are similar to each other. We want to do the adding and subtracting. So that's what we're trying to do. We've got to make sure that the terms we're trying to combine have the same letters. Sometimes it could just be the same letter. Sometimes it could be a combination of letters. And they have to have the same powers or exponents on that letter. And I'm happy for you to use whichever word you're more comfortable with. So that's what we're going to be looking for, seeing which terms have the same letters and the same exponents and combining those. Okay, so this section I find looks a little bit confusing. It says to combine like terms, first use the commutative property to move all like terms together, then combine the coefficients of the variables. So you can see in this first example, they put red squares around the terms that have a's in them, and then they've just reordered them. So getting from this first line to the second, they haven't really done anything other than moving the terms around. One thing to be really careful with is you'll notice with this 4a term, they have put a box around the 4a and the subtract sign in front of it. And so we're kind of reading that as on its own negative 4a, but when we move it, it becomes 2a minus 4a. It's really important that we take the sign in front of the term. If there isn't a sign in front of the term, like the 2a at the beginning, we just assume it's positive. I don't actually do this when I simplify by combining like terms. I do what they do in example 2, which is I circle the term and the symbol in front of it, and then I combine them. So I would combine the m's. I've got 14m and 3m, so I'll just say that if I've got 14m and I add on 3 more, that is 17m. And then I'm going to look at the ones that they've circled in blue. I've got negative 3n squared, and I want to take off another 2n squared. So that's going to go down to 5n squared. All right, in example 3, there's nothing there. So this is what I'd do. I would start with the x squared terms. There's only one of them, so I'd write that first, 5x squared. I'd then go through the x terms. I'm going to use a different shape because I'm sure you don't want to be using tons of different colours. So 5x plus 4x, that's 9x. And then I've just got left the constant term, which is minus 6. Now, I chose the order that I wrote those in quite deliberately. There weren't any different letters. If you look at the example before, I decided that I wanted the M's to come before the N's. And all I'm making sure I do there is that they are in alphabetical order. In example 3, there's only one type of letter, which is X. But I decided to do the X squareds first because what we normally do is we go from the greatest power to the least. And these are just conventions of algebra. So it's what you will see typically if you read some maths, is what people expect to see. It doesn't mean it's any different if you write it in the other order, but it just might not look right. So it's not necessarily wrong, but it won't look right to somebody who's reading your work. Okay, there's a few common mistakes to look out for. So they are actually all things we've already mentioned. So we'll just run through them quickly as a bit of review. The first example, making the mistake that A squared and A's are the same type of term. So because they've got different powers, we can't do this. So I'm just going to write different powers. The terms that we could combine are the minus 4a and the plus 5a. Those do have the same power. A is just to the power of 1. Okay, mistake number 2 is getting all in a muddle. Actually, what have they done? They've done 2 mistakes. One which I think is not intentional. So this is, they've missed out the 3. I don't think that's a mistake they're going for. What they're actually saying is it should be in alphabetical order. That's not my biggest worry. So mistake 2, I don't think is as important as mistake 1 and 3. Mistake 3 is the one that is a common mistake, and you'll notice that they are just highlighting or putting boxes around the term. They're ignoring what comes before it. So this negative sign here has just disappeared, and actually it's ended up with the 5G at the end. So the mistake here is they're forgetting that we need to take the term and the sign in front of it. Okay, there's some practice on the next couple of pages. I'm going to get rid of this question because I don't like it. So you can work through some of these. You can work through some of these. I would say if you are really confident with this, don't feel you have to do every single question, but make sure you're doing some questions from each section. I think everybody can do all of the first one, even if you are really confident. Let's just look at one of these just to give you an idea of what I'm expecting to see. So if I was doing question 33, there's not room to do this on here. So I would be doing this in my notebook. So here is the question. That would be the first step. Okay, I'm going to go through alphabetical order. So I'm going to do the D's first. 11D minus 21D, that's negative 10D. Then I'm going to do the F's plus, there's only one F term. Okay, that's easy. And then I'm going to do the constants. Constants come last. So 5 minus 8, that is minus 3. And there's my answer. You'll notice that I did put an equal sign in. The top expression is equal to the bottom expression. It is simpler though, because instead of writing it with 5 terms, I've written it with 3 terms. So I've simplified the expression by combining like terms, which is what we are doing today. Folks, I would like you to work through at least some of the questions on page 7, and I'd like you to work through all of the questions on page 8. If this is really review for you and you can blitz through it in 10 minutes, what I would suggest you do is you go to Sparks and you look at the Target XP. The Target XP is questions that should extend you a little bit further beyond the regular homework. So it's going to push you a little bit further, which I think could be what you need. Also remember, you can check your work. If you look on OneNote, underneath the unit booklet, there are all the solutions. So you're going to be going to day 2. And we should have solutions there. Okay, best of luck.